this set of notes, your title is Write Linear Equations in Standard Form. So you should set up your own Cornell notes. And again, as this page here identifies your title. Here's your essential question that you should also write in. How do you write an equation in standard form? And here's the start of your note. Here's the standard form, ax plus by equals c. A and b cannot be 0. Here again is the standard form equation, and if you notice here on the left side, all of the variables are on that side of the equal sign. And on the right side, all of the constants remain on that right side. So this is one little helpful tip when rewriting equations in standard form. You have all your variables on the left side and all of your constants on the right side of the equal sign. Alright, so now for our subtitle, we're going to write an equivalent equation in standard form. Here we have example 1. 2x minus 6y equals 4. And again, as you can see, this equation is already in standard form. We have our variables all on the left side of the equal sign, and we have our constants on the right side. Step 1, you want to choose a number to multiply each side of the equation by. And you can choose any number. In this case, I just happen to choose 2. Nice even number. Step 2, multiply each side of the equation by your chosen number. In this case, the chosen number happens to be 2. So here I have the original equation, 2x minus 6y equals 4. And as step 1 stated, or excuse me, step 2, we're now going to multiply the left side by 2 as well as the right side of the equation by 2. We apply the distributive property, multiply 2 times 2x to get 4x, and multiply 2 times negative 6y to get negative 12y. And then we do the same with the right side. We multiply 2 by 4 and we get 8. So we put a box or a circle around our final answer. 4x minus 12y equals 8. And again, this is standard form because we have all of the variables on the left side of the equation and we have the constant on the right side. Now it's your turn. Write another equivalent equation. The next subtitle is Write an equation from a graph. And here we have a coordinate grid, so you should also draw this onto your Cornell notes. And this is example 2. We have 2 points. First point, 1, 1, and our second point, 2, and negative 2. Step 1. First thing we have to do is calculate the slope. Since we have an actual graph, we can calculate the slope by just determining the rise of a run, looking at if we're actually going up or if we're going down, and then determining what the run is. Are we going to the left or if we're going to the right? In this case, our rise is 3, and then our run happens to be negative 1. Simplify that and you get negative 3. Step 2, write an equation in point-slope form using either of the points from the graph. So on that graph, it doesn't matter which point you choose either one of them, and then use that to create the point-slope form that we discussed yesterday in class. So here is the point-slope form. And so now we're just going to fill in the values based on what we did previously in class. So the very first point that's being used in this case happens to be 1, 1. So I substituted in a y sub 1 for positive 1 and replaced m, our slope, with -3. And then substituted x sub 1 with its value, which is 1. Or if you would have rather used the second point, which is positive 2, negative 2, would have worked as well. Same process. Step 3, you're going to rewrite the equation in standard form. So, as you can see here, there's my point slope form. And in order to get this point slope form in standard form, I need to first apply distributive property. So we're multiplying 3 times x, which gives us negative 3x, multiply negative 3 times negative 1, which gives us positive 3. Now our focus is here. And remember, with standard form, your goal is to have all of the variables on the left side of the equal sign and your constant on the right side of the equal sign. So in this case, I'll want to go ahead on and get rid of this constant. And so we can do so by adding 1 to both sides of the equation. And once we do so, we end up with this portion here, y equals negative 3x plus 4. I'm almost there, but not quite. I want the variables to be on the left side and the constant to be on the right side. So the variable that needs to be moved in this case is the x, or more specifically, the negative 3x. So we're going to add 3x to both sides of the equation. And once we do that, we end up with 3x plus y equals 4. Again, the variables are on the left side and the constant is on the right side, and we're going to put a box or a circle around that final answer. Now, if you used point to negative 2, the process is still the same, and if you work it out correctly, you can see that we still end up with the same standard form equation. So no matter which of the points you use, if you work it out right, if you use the correct process, you still will get the same standard form. Now it's your turn. Write an equation in standard form of the line through the 2 points that are given. So as you can see here, we don't have the actual graph, we have the points. So what will need to take place since we don't have the actual graph? Go on and pause, work it out, and then go on to the next, or let the video progress and see if you actually come up with the correct answer. Did you get negative 2x plus y equals 7? If so, fantastic job. If not, that's okay. Review your notes and go back and look at your work and figure out what mistakes you made.